Hello everyone, welcome back again Search Creator World. In the last video, we're going to understand the experiment number 3, iris dataset, and what is iris dataset, how to load this iris dataset, and how to reduce the iris dataset into 4 features to 2 features. Okay, so I hope you understand that program. Now we're going to understand the experiment number 4. The experiment number 4 in the PCSL code and BCSL 606 code, and laboratory is machine learning. Okay, so now you're going to understand the what is experiment number 4 name. For a given set of training data example stored in a CSV file. Okay, so they give the some sample example like sunny, warm, and wind play tennis, like this sample data set where they give. So we're going to save that sample data into CSV files, but in this case we're going to load the direct what is the sample data given direct. We're going to load the from machine learning code and also implement and demonstrate find S algorithm. So to output a description of the set of all hypotheses consistent with the training examples. Means if the we're going to understand, means we're going to play tennis in a field. So using the in machine learning using the find S algorithm. What is find S algorithm, and also what are the symbols used in find S algorithm? Now we're going to understand. After that we're going to enter into the code. Okay, so let's get started the video. Now we're going to understand the what is find S algorithm in machine learning. The S algorithm, also known as the find S algorithm, is a machine learning algorithm that seeks to find maximally specific hypothesis based on labeled training data. It starts with most specific hypothesis and generalize it by incorporating positive examples. It ignore negative example during the learning process. This algorithm objectively is to discover hypotheses that accurately represent the target concept, progressively expanding and hypothesis spaces until it covers all positive instances. The symbols used in find S algorithm: question mark, empty set. This symbol represents the absence of any specific value or attribute. It is often used to initialize the hypothesis as the most specific concept. Don't care term, the question mark represent I don't care or unknown value of attribute. Positive example, this plus symbol represent positive example which are instance labeled as the target class or concept being learned. Negative example, minus, the minus symbol represent negative example which are instance labeled as non-target classes or concept that should not be covered by the hypothesis. Hypothesis H, the variable H represent the hypothesis which is the learned concept or a generalization based on the training data. It is refined iteratively throughout the algorithm. Now we are going to understand the line by line expression of find S algorithm. The first we let us importing libraries. The code is import pandas as pd and import numpy as np. Pandas a tool that help us work with label tables like Excel in Python. Numpy a tool work with numbers, arrays, mathematical operations, like not used much this code but often used in ML. Now we define a class to represent the find S algorithm. Class find S, we are creating a new blueprint called find S. This help us to group function together that do the find S algorithm job. Initial setup, when we creating an object of find S algorithm, define initial object. Self hypothesis is equals to none, self future is equals to none. Initial function is a constructor, it run automatically when we create find S object. We set up two empty things, hypothesis our guess for the right condition. Features, this name of the columns like sky, wind, S. Think like setting up your notebook before starting homework. This is the example. Create a most specific hypothesis. Define initialization hypothesis. Self num future return num future multiply num futures. This creating a string starting hypothesis like alpha means nothing known yet. Imagine best example. Imagine you don't know what weather is good for playing tennis, so everything is blank. Check if an example is positive. Define a function is a positive example. Self comma target return target is equals to yes. This check the if should learn from this row. We only learn when we answer is yes. Positive example. The best example, we only want to learn from happy stories. If someone says I don't play tennis, we ignore it. Next is generalized hypothesis using positive example. Define a generalized hypothesis. Self example current hypothesis, new hypothesis. For example value hypothesis value is in zip. Example current hypothesis. If hypothesis value is equals to nullify. Hypothesis dot append example value. Elif example value is equals to hypothesis value. New hypothesis dot append hypothesis value. Else new hypothesis dot append question mark. Return new hypothesis. Let's say your first good experience was sunny, warm, high humidity, weak wind. Your guess become like this: sunny, warm, high, weak. So now another good one is sunny, warm, high, strong. Since strong not equal to weak, you generalize the last part to question mark. New guess become sunny, warm, high, question mark. This function run the find as learning process. Define fit self data target columns. Data table with example target column with the column we are trying to predict yes or no. X is equals to data dot drop columns of target column. Y is equals to data target column. X is equals to all columns except targets. Y column is equals to columns with yes or no values. The code is self dot features is equals to columns to list function. Self dot hypothesis self initializer hypothesis lens. Self dot features say the columns like sky, temperature. Start hypothesis with nullify. 4 nullifies. And code is this everyone row, this every row. If it is S example, we update our hypothesis is it. Display the final hypothesis. Print hypothesis self. Show the final result in a nice format. Sky is equals to sunny, temperature is equals to warm, humidity is equals to high, wind is equals to question mark. Means tennis is played when the sky is sunny, temperature is warm, humidity is high, and wind can be anything. Okay, load the data from the file if not used in this example. Tries to load the from a CSV file not used here, but helpful for user to try their own file. Okay, so main function to run everything. Diff main function sample data sunny, sky is equals to sunny, rainy, sunny, temperature is equals to warm, cold, warm, humidity high, wind is equals to weak, strong, weak, play tennis yes, no, yes. Data frame PD is equals to data frames. Sample data table is made with weather conditions and whether tennis was played, like writing a diary of days you played tennis. Run find s algorithm. Find s is equals to find s dot fit diff of target column is equals to play tennis. Find s dot print hypothesis. Create an object of our find s class. Learn the hypothesis from the data. Print the final result. Final print instruction. Print hypothesis interpretation. Question mark means any value is acceptable for that attribute. Nullify means no value has been observed null. Hyphen specific value indicate required values for that attribute. Helps with viewers understand the output easily. End of the program. So we're going to run the main function. tell Python run, we will start this file. Example experiment sky is equals to sunny, temperature is equals to warm, humidity is equals to high, wind is equals to means I will play tennis. It's sunny, warm, high, and wind does not matter. Okay, this is about the experiment 4. I hope you understand a line by line expression code, and if you anyone having the doubt means in the experiment or else any about the machine learning laboratory, so we will help you to your clarification. Okay, so we will help you, and below description box we will link the our mobile number, and also we will provide the who already not download the machine learning laboratory program PDF. We will also provide the link, and we will also provide the our website link. Go and check it out, and after that share this program to your friends or faculties. Thank you for watching this video.